Forest restoration is one of the major challenges that our society is facing at the moment. However, in spite of the great conservation efforts, drought is still one of the critical causes of seedling mortality after transplanting in the field. It is not uncommon that only half of the planted seedlings to survive in areas with limited water availability. And under climate change, these droughts are expected to increase in frequency and intensity in many regions. There are many characteristics that increase seedling survival under drought, but one of the most difficult ones to study are root systems. For example, seemingly simple traits such as rooting depth or branching density are very difficult to measure in the field. The objective of our project is to analyze the effect of drought preconditioning on root architecture and growth dynamics of three American forest species: Douglas fir, western larch, and black walnut. To do so, we transplanted 1-year-old seedlings that have been drought preconditioned through exposure to hydric stress during last year into these big and tall 3 pots, where we can simulate drought conditions and control water availability. We are studying the root systems of these seedlings using an X-ray computed tomography scanner that allows us to do non-destructive measurements of root growth dynamics and architecture. Through this method, we can periodically construct a 3D model of the root system in order to measure important characteristics for seedling survival, such as root elongation rate, rooting depth, branching density, and lateral root angles. We hope that this study will help identify root traits that can confer seedlings higher drought resistance and explain differences in survival among genotypes of the same species. We also aim to identify nursery treatments that could enhance root development and increase seedlings' field performance in arid regions, and therefore ensure the future success of forest restoration under climate change.